downtown Mill Bay. Good day, good day.
Loquísimo. O sea, sí que me dijo. Pero tampoco creo que esté como así súper. No, pero tampoco como las ilusiones porque eso va a acabar bien.
Why are you wearing your uniform? Oh. Okay.
I support going.
No, but so. Actually, also your laptop's out and respond to the email that was sent to you earlier today. The form, the ATLs. I just resent it to you. It's on your email. It's not in the Google Classroom. If you could fill it out now. And if you are in both of my classes, yes, you will have to fill it out twice.
What is wrong with your eyebrow?
So today, right now, do it for Science Now.
It's like losing one option. That's like a yes or no question. Ready?
Hello, why are you late?
I'm on time.
What? It's on 10. Yeah, you just got to be seated, ready, set to go.
Get some patience.
Can I have your laptop? Answer the form that I just sent. See here. Email out. Answering the form I just sent. Let's go. Go, 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 go.
You've never seen me before.
Headphones off, Bertie. Bertie. Headphones off.
I have a better personality and looks in me.
Gentlemen, do I need to separate you? Focus on your task.
It's only 30 minutes.
arguing about it. And then you drew Timmy into it. Poor Timmy, doesn't want to hear about it.
There's no alternative on.
You go, are you done?
Oh, no.
Taking attendance in a moment. As soon as this loads, I'm gonna have to slow it. Maybe because I just told everybody to get on. Yes, I see you. Put it in your bag and away where you won't grab it. No, yeah, in your bag. In your bag. Put it away. And Jonah. There. There we go. There. Zoe. Lisa Felix. Matthew William K. William here today?
He's at hockey.
He's not marked off though. Alejandro? Yes. Ferdy, Karen, Lynn, Naomi, Hugo, and
Do it in science and if you want right now.
No. I'll give you time at the beginning of science TEDx tomorrow to do that. Once you're done, Put your laptop away. And then pull your nose. I'm gonna put some blood squares for you. Blood cells. Also, for those preparing mentally, our blood typing lab will be most likely Friday. This Friday.
Yeah, I was gonna say like emphasis for them. Oh wait, no, I am.
Good. That is now good.
But also like, what are the details for that? So like, we're
You're gonna stab
make
yourself,
our fingers.
and you're gonna put blood on the thing, and you're gonna mix your stuff, and you're gonna put it in.
Oh, so it's like, I thought we were, cause at first I thought we were gonna.
There's no way I can do it myself. I'll check it out.
See if we can pull up right to it. It's just a cool thing to look at.
Whatever works, I guess. Do not.
Ahem.
What? No, it was Zane's question.
Zane?
It
Stop that. Zane? Yeah. Is anybody still ready yet? Almost done, Timmy? Okay, we'll wait.
Give me a second.
You need to know about the lab. I was thinking of doing the lab in here at first, because you can all sit down and not crack your head against the floor if you think. However, Ms. Stewart was like, it's way easier to decontaminate the lab, you know, in case you have a bloodborne disease, like HIV or the flu. And so that's true. So we might actually just drag our chairs into there, so that while you're doing it, you're just seated. Apparently no other class makes their students do that. I have had the most concussions in that lab, and I think the other teachers have had none. So maybe it's just me. Yes.
Are you allowed to get someone else to prick your finger
Yeah.
for you if
You
you
can do
don't
whatever you
have
want.
the strength?
It's all about. The important point is it's about consent. So you can't do it unless someone has asked you to. So you can't run around the room and randomly poke people with your fingers.
Can you do
Stab.
something other than the
Yeah.
finger, because the fingers, if you use lots, and then it's guessing.
So yeah, do your left hand.
You're gonna break through.
Yeah. You want to do the pad at your finger because that's where there's lots of blood. If you do it in other places, you're just not going to get enough blood. And you know, doing weird places like your cheek and stuff. Very hard to like. Also hard to manipulate on to get blood. You know, get stuff out of it. So yes.
What if I get a staph infection?
Then we good thing Canada has healthcare. There's a chance that you could get any sort of infection every single time we do this. So the important thing will be that you will sterilize it first. You will then make sure you wash your hands. But it's a tiny little pinprick. You get a lot of those probably every day doing a lot of different things, and possibly don't even notice them. But yes, there's always a risk in any lab. So we take as much safety precautions as we can, but there is a risk. Have you had a staph infection?
Yeah.
Could you put your phone away? Put your phone in your bag. In your bag, not your pocket. Okay. Hold it. I thought I saw it. You done, Timmy? Notes should be out then. Paper out. See here, paper out. Those are known as antigens. They're involved in cell recognition. They're also, when you have a foreign invader, like a bacteria or a virus or a Staphylococcus bacteria, your body makes antibodies against them. And it only does it against foreign antigens. So your own antigens, your immune system was trained once you were born not to attack your own antigens. If that goes wrong, that's called an autoimmune disease. Rheumatoid arthritis is an autoimmune disease. It is when your own body attacks antigens in your joints and you get arthritis. They have shown it's partially genetic. You can be more inclined to it. But everybody who has had rheumatoid arthritis always had a very bad case of this, usually a number of cases, of a certain type of flu when they were younger. A lot of the flu viruses, to fool your body into leaving them alone, will coat themselves in antigens that actually look similar to human proteins. And so some of those look similar to joint proteins, and that's why eventually your body gets trained against it so well that it starts attacking your own joints.
Is that why some people get sicker and some people less sick? Is that some people can recognize it better because they're trained to look like one of them, but then the other person
Yep.
looks different?
It is, I can't remember what law it is in disease biology. Timmy? Quietly. In biology, in that in every disease, you will always find members of the population who are immune. You are born with all the antigens you can ever, antibodies you can ever make. So if there's a disease out there that can kill you because you don't have the antibodies to get it, you can't make it. The combination's already set. You have a lot of them, billions and billions, but if that disease manages to evade yours, it's just evaded. You can't invent a new one. But everybody has slightly different ones because they have two different parents. So there's always a group. There are people who are naturally immune to HIV. We found out there's a small population that have a mutation on their cell walls that actually prevent the virus from entering their own immune system, and that allows their own immune system to attack it. So there's always antibodies against something. There is one famous explorer who, by all, not just his own accounts, was never sick in his life. No cold, no flu. Apparently he had the best immune system that had everything. But it also depends on how quickly your immune system ramps up. So if you have a really good immune system that turns on quickly against antigens, then you might actually feel very sick because you have a temperature spike and your body's slowing down because you're fighting it so hard. So there can be a lot of different effects. Also, if your immune system is really, really good, then you will have things like hay fever. You'll be allergic to cats. Allergies are your immune system reacting incorrectly against antigens. So, yeah. You can become allergic to things because you're exposed to them so often, your body just starts making antigens even when it shouldn't. There's a famous Barbara McClintock who did a lot of first research on jumping genes, since we're doing genetics anyway. Very famous researcher. She's allergic to corn because she worked with corn plants for her entire career. And so corn pollen now sends her into a very bad hives because she worked with it so often. Important fact, if you like to drink coffee. Researchers who do all their work with cockroaches and are cockroach experts find that they become allergic to instant coffee.
What does that mean?
Cockroaches in coffee.
It means cockroaches are allergic to instant coffee.
Yeah. Along with other
Apparently when you roast things and then you grind it up, you probably don't have to pay as close attention to picking out the cockroaches if they can't see the beans.
The allergic to cockroach there, it's just anything that has the
Parts.
it has the same thing as the cockroach. I can't remember. It's basically how they absorb the oxygen. It's what
Yeah, we don't need to go that much.
But it's from all types of bugs like that.
But for
Spiders
coffee,
as well, and-
it's definitely cockroaches because
Wait,
we've
so we're
seen how
drinking
they've made it.
So it just
Yeah.
falls in.
Oh, okay.
It gets roasted,
But instant coffee's
and if you're taking regular coffee, you'll pick out the bugs because you're selling the beans. But if you're just gonna grind it up and then put fluid through it and make instant coffee, what's the point? It's not gonna harm you
Okay, who cares?
unless you're, allergic. Okay,
Can you imagine just drops that?
Last one?
Cockroaches weren't on the ingredient
Karen?
list.
The genetics for all of these is slightly different. AB is the easiest. If you have type AB blood, then you have the alleles A and B. If you have type O, though, there are still two genes. You have O for one and O for the other. That means you have no antigens. If you're type B, you don't know which one of these you are. You either have B for both, or you have B for one and O for the other one. You are still type B if you are BO. If you are type A, similarly, then your genetics are AA and AO. You don't know. So if you know that your mom or dad or you are type A, then they could be either one of those. You're not entirely sure, unless they've had some sort of genetic testing. So the first task, Father is type B, mother is type A, child is type O. Prove with Punnett squares any particular conclusions. You do need 2 Punnett squares.
Can I just ask a question?
Sure.
So the first one, it would be the father is AB and the mom would be AA, and then the second one would be the father is AB and the mom is AO.
Yep, you just now perfectly explained the thing that I was going to walk around and check.
So,
So father is type A, B, and for the first one, mom is type
AA.
AA. And then father is obviously AB, and mom could also be
AO.
AO. So there is an O there. Go through the different types. What would we conclude about this child?
Are they all uppercase?
Pardon?
Like, is like blood always uppercase?
Blood is, yes, always uppercase. How would you know to feel that?
Sorry?
Keep going. Don't look at hers. How are you putting 2 pieces on that? So you did that one. I think you looked over there, but that one was there and that one was there. So with that one, what would you put down here? And yeah, it doesn't matter the order. So. And now combine. Yep. Yep. And then you have to fix that one. Why would you put BB for that last one? Why would you put B out? There you go. And alphabetical order when you're done, but that's fine for now. What would this one be?
Yeah.
Right. So erase what you got. B out. It's hard to read if you do that. You'll never know what you meant. Do you not have an eraser? Oh, okay. There you go. And it done. Don't worry, I'm not going to stand for you actually the whole time. Why AP? Remember when I said that I wasn't going to stand here and watch you the whole time? Yeah, that's not.
Yeah.
Yes. Doing what? Perfect. Hold it. Yeah, I think it's because you had a B underneath. You want to erase just to make sure, or do something so that you can see it. Okay. So we have AB, AO. Your blood type should be so for this one here, what is the percent chance of type A? 50. And what else is possible? AB, what percent chance? 50. So I'm doing the phenotype right now. Not too worried, the genotypes are all there. So for this one, what is the percent chance of A?
No, 50.
Not 25. 50%. Because that is type A, and that is type A. They're both type A, so we have. What other types can we get from this one? AB. What's the percent chance of that? 25%. And what's the last one? B. Percent chance of that? 25. Excellent. If the child is type O, adopted. Or something very weird is happening genetically.
Mutation.
Could it be a mutation or no?
That would be incredibly rare. The mutations on the blood aren't that common. It could be. It could be that the woman is one of those 1 in 800 million, that chimera one. There could be something going on genetically that we haven't seen before. Commonly, it would mean you're not related to at least one of your parents. Could also be mixed up at the hospital. There's all sorts of conclusions. It could be father is type AB, mom is type A. The BC Children's Hospital has had this happen to them. They said, we have to have you in for genetic counseling because we want to know the odds of you having another child that has this genetic disease. It's a recessive gene. So they get mom and dad, hear the explanation, they agree, they both come in, and then they say, okay, so your genes were this. And then the dad's like, but I'm the stepdad. And they're like, yes, we asked you before, like we were going to do biological counseling. Why are you now telling us that you're stepdad? And the parents still showed up for genetic counseling, not realizing that they didn't need to worry about it anymore. Very odd. So, also, could be stepdad. Difficult for, actually, theoretically, it could also be stepmom. Yeah.
Wait, what? So why isn't it 50? I mean,
For which one? Which one are you looking at? This
No,
first or
20.
second?
yeah, why is it 50 for type A?
Because, what type is this?
A,
That's A. What type is this?
A.
No, but phenotype. This person has type A blood. You never. That's recessive. You never see it.
Oh,
So no, O is another type of blood. So the phenotype is A is 50%. If you were doing the genotype, then you'd be correct. 25% AA, 25% AO. Does that make sense? Okay. So child is born blood type A. The mother is blood type AB. The father is type B. Are these likely biological parents? What are the odds? You've got two Punnett squares. We've already done number 2. There you go. So, what are the two possibilities for dad if he's type B?
BO or BB?
Right.
So,
So
do.
dad, you have to do both. So which one of those is mom? Yeah, on those two. Which one of these is mom? Okay, and which one's dad? What blood type is dad? Nope.
Oh,
B. Right, so that's one type. What else could dad be?
no, it's B, B, or B.
oh.
Not just O. I mean, he's type B. So BB is one type, one way you can get type B. What is the other way you can get type B? No, then you type A and B. That's BB. What's the recessive one? Oh. So it would be BO. So,
So, do you have for BO?
yeah, so you put BB there, but that's why we did it twice over here. We had AA and AO, because we didn't know which one, the father's type B, the mother's A, but we didn't know which one the mom was, so we had to put AA and AO. If we don't know the father's type B, you have to do BB and BO, and check them both. And then same mom for each, because AB can only do one type. Then put them through. You're the one.
So what do like AB plus say? What's the difference?
Plus is just another factor. So you could be you could also inherent the RH factor. The RH factor, if I'm gonna erase this after, so I don't. There's an equivalent, like you can be positive for RH, and you can be positive negative. If you're negative in both genes, then you don't have it, and you're RH negative. If you are positive negative or positive, then you're RH positive. So it's another set of blood
Is then
typing
the
genes.
negative a recessive gene then?
So the negative is recessive. It just means you don't
So
have
why
it.
isn't it not a small plus? 'Cause, like,
Oh, it's just in the same way that we didn't use a small A or B for the recessive here. We just called it O. It's just tradition.
Do it yourself.
The people who invented it did it that way before we fully accepted what the different ones. It was discovered afterwards, and it was discovered through a really kind of sad but obvious way. They knew AB blood typing, ABO, and they carefully matched people's blood, and it saved a lot of lives. But in 10% to 15% of cases, the person died anyway, clearly dying from the wrong blood type, even though they correctly matched it. So they knew there had to be another factor. Yeah, and they discovered it using rhesus monkeys, so they would give human blood to rhesus monkeys in a variety of ways to use their immune system to see what it was reacting with in human blood, which is why it's an RH factor. Okay, check your work. We've got AB for mom, and father is BB or BO. Always sounds like they are smelling.
Mr. Newfeld,
Yeah.
why is it AA for the second one?
Did I do something wrong? Oh, that should be AB. Yeah, no, that's just me writing things fast. What am I doing? Did I do the other part? Okay, using this Punnett square. Let's go with William. Ren?
Yeah.
What other blood types that you can get out of this?
A, B, and B.
A, B, and B. And then I ask someone else, what are the percentages for each of those blood types? See here.
50 and 50.
50 and 50. So for this particular pairing, what's not possible? O
A.
and A. But we don't know if it's this. Okay then. Your sound is going away. Lisa, what are blood types are possible in the
They
second
don't
one?
have any antigens.
AB?
AO.
Nope.
A.
A
Because this
And B.
blood type BO, because that's not antigens, it's technically B. That's why AO is technically.
Nope, still going. Stop beeping.
That's what yes.
Alejandro, what is the percentage of AB?
25.
25? 25? For AB?
No, but if that one, like the other AB that is done, it is B and B at the top. No,
Oh, did I do something wrong when I was correcting it? Yeah, I did. Hold it. Let me just double check what I did because I wrote it wrong to begin with. A, B, B, O, A, B, A, O, B, B, and B, O. Excellent. So, 25%. What's the percent chance of A?
25,
25 and B?
50.
50. The child is born with type A. Would we be able to eliminate the child as a potential child if we were trying to figure out genealogy? Or is that a likely child for this couple?
So
It's likely child. It's entirely possible that that could be the child. They're type A. We've got type A right here.
Does that mean that the dad's B?
We would assume then that this is only the way that it can work. So we assume that the dad is BO. And that means that he does have a recessive gene, and so type O in the future could pop up in the grandchildren. You can see how this would be used at crime scenes. If the person who committed the crime left blood behind, you'd be able to eliminate all the people that didn't have that type of blood. If you're looking at tracing genealogy, which has been done for things like the royal family, so they know the blood types of a lot of the more royal families, so they can figure out, oh, this person was actually related to this person was related to that person. Oh, look, the person who said they were related to this person wasn't, and we can figure that out. Now, we have one now on Maury. I don't think Maury's playing anymore, and I don't know if they have daytime television anymore, where they bring out people and say, you are the father. I'm going to have you do this one on the board. Find your person. Get together. And I want you to tell me. Find your person first, and I'll put it back to the problem. Go to a board, grab a pen, erase what else is there.
We're just doing all of them.
Yep.
Okay. Alright, start throwing. How all of them? How much?
There's quite a few. Now on Lori, which of these four guys is the father? Possibilities are Dave, type A, John, type B, Tom is type AB, and Rex. Rex is type O. Betty Ann Ray, the mother, is type B, homozygous. We happen to know that because she tested herself to make this easier. The child is type AB. What are the likelihoods? And I want you to prove it with Punnett squares.
Jonathan, can you pass me the picture?
So the first one, does it matter what
Label your Punnett squares. So if you're doing Dave, label it Dave. You have to do 2 for Dave, which you probably do. Do 2 for Dave.
Homozygous means that they're both the same, right?
Yes, homozygous means they're both the same. And we only know that for Betty Ann Ray.
So you're doing Dave and John, okay? A and B.
So here, who's your partner? Oh,
And who is this?
is he having a chat? Excellent, getting a marker.
Yeah. No, that's the option. So you have to choose. The mother is
Heyo.
B.
Okay, wait, so what about this? And then this is but she's homozygous. Type homozygous.
Oh,
So I'm doing Jane and John.
Oh, so AO is Dave.
So that's A and B.
So who could be the father and who's most likely to be the father?
So you're just doing Dave right now? So A,
not for so but because I'm not for
Oh, yeah, wait, this is
yeah, do her on top of that.
Okay.
And then do B that one.
You can erase the chemistry that's there, William.
So
Makes it easier.
We need 2 for each. Because,
Zane, who are you doing?
And this is John.
I am doing
And then
Is that
next,
Tom, Dave, what? Label it Dave so we can see. Yeah, just label it top Dave, because the mom's going to be the same
I
each
feel like
case.
there's more Punnett squares than we need.
Oh, there might be.
Okay.
I just gave a lot.
Oh, okay.
Yeah.
oh, Lori's the child. Wait, will we have to use all 9 squares? Yes.
Not necessarily, I just made a lot. I made more than what we need.
For Dave, okay, the options are A.
Or do we have to do all of them?
Pardon? No, you can just use what you need. Oh, you should check them all. I want you to prove whether each one of them. So you have to do Dave, John, Tom, and Rex.
Or BO.
But you don't have to use every single Punnett square. You don't need every single Punnett square. But I do want you to do the exercise.
Yeah, so the it cannot be right.
And then that's it.
So the AB, there's no AB. Yeah, it cannot be right.
We don't. So the thing is, we only know one of
But then what's
his
the
alleles,
kid?
which is B.
The
And
child
the
is
two options for
AB,
B,
so the
B,
only
B,
could
B.
could be
Maybe like circle.
Could be that good?
Okay, so it cannot be
Yeah,
John.
wait, which one was that? Because you got 50%.
It cannot be John.
No, I forgot which one I was.
And then
It can't be red.
Julie.
For because AB was like
I think the more
Okay.
likely
No, this is a second one.
that
You just spelled Rex is on.
That's what it is.
Yeah, so they
Correct.
So many people do that.
O is yeah.
That guy.
It looks wrong even though it's right. I spelled it. No, I wrote it. My handwriting makes it
The
wrong.
child is like this. So we have to stay.
Child is type AB.
So it could be both.
Okay.
How-
Do we have both A's? And then we have AB and O. Okay, we're good.
Dave,
Either Dave or Joe.
I mean,
More like
the child is type AB.
So I'll tell you.
Yep.
So, Dave is
I know that.
So one of these are the two parents.
So either
Where, like, it doesn't matter. So
We don't know what Dave is.
yeah, so Dave would be either 100 or 50.
Yeah.
It's like 7 of us.
Yeah.
Why didn't nine? Or Dave might be 50 because he could get able.
No, so
Yes, it could be.
Rex is like,
Since we only
so,
know that Dave is an A, we don't put two options for A are AA or AO. If
So you got
two
this
squares
right.
things to see.
Yeah, you
Like
know,
this
so
page
it says a B or
so
B.
A can be AA or AO, B can be B or BO, whereas these can only be the same thing we ever said. So you write AA, and it's just like the Mandela things. You put one of the letters H.
I mean, Dave is
the other kind
But
of
I get how to make it.
You want to? Yeah.
most like.
Don't worry.
Alright, so what did it say what the child is? Child is type AB, so which one's, so Dave could be,
I mean, what's the child?
and Tom could be the father. I mean,
This my guy Dave. What about his Joe? Yeah, he still has a Joe. Yeah. His name is Tom.
His name's Tom. Yeah. So who can you eliminate right away?
John and Rex.
John and Rex.
John and Rex. Because neither John nor Rex have an A. So clearly they are not the father. What about Dave and Tom? Is one of them more likely than the other?
Dave.
Dave. Because you don't know, but he could be AA, but he could also be AO. But since you don't know, it could be either way. That gives it a little higher chance. Could it be Tom?
Yes.
Yeah, no, it could be. It could be either one. Dave is probably the most likely father, but most likely is not always what comes out in real life. So we would want to investigate Dave and Tom a little bit more. No, not the father.
Lady,
And keep in mind, when we are using terms like most likely in genetics, what that means is if 1,000 people had children, we'd expect it to correspond to the probabilities. But if you've ever flipped a coin and gotten like 5 heads in a row, you know that in the individual, anything could happen. Okay. Sex determination and traits. So, looking at
Sorry.
Alejandra, question? You had a question.
Yeah, but I just asked her.
Okay, okay. looking at our sex determined traits, so this we're only talking about gender in terms of genetics right now. There are some traits that only exist on the X chromosome. And so, first, how do we get genetic determination from that? This pairing is historically the pairing that you would always use. In the future, when we have ways of dividing up eggs perhaps in other ways, we may not have to do this. However, currently this is the way. You have a genetic female potentially and a genetic male. You do X and X, and you do X and Y. And then what percentage of children should you get, male and female? 50-50. Now, if you've ever seen a family that has like all 5 children are daughters, or all 5 children are sons, or female or male at birth, you will know that in the individual that doesn't always happen quite that way. But 50% genetically female, 50% genetically male. It is a little bit more complicated than that in the environment because the little spermies can swim at different speeds and the egg has a choice. So we used to teach this way back when as the first little spermie to reach the egg was the winner. And now we have learned that that is not the case. The egg undergoes a complicated process in which it will evaluate the fitness of the first few to arrive and say, I want that one. And so there is some choosing that goes on as well that's complicating the process. Because we know slightly more males are born than females. It's still pretty much 50-50, but when we're looking at populations in the millions, we're expecting it to be dead on 50-50. And it's not. It's always slightly more males. So there's something else going on there that we're not entirely sure as the reason why. So there is off.
Isn't it by the time you get to adulthood, it evens out to be about 50-50? It's only in kids that's 51-50.
Even in adulthood, I think it's still slightly skewed, but that may depend on country.
And then also once you get to like past like 60, there's more females.
That is often misreported. Yes, males die earlier, but also so do females. What you'll find is that there's death waves. So first the males die off, but there's some males who survive, then the females die off. But there's some females that survive, then the next batch of males, they actually happen as waves. And so the first wave is the males. But the second wave is the females, and all of a sudden in the old age home, of that age group, the males outnumber the females. One of the proponents suggested was that since males are more likely to get into accidents or fight in a war or something, then it might be that. On the other hand, in countries that regularly say go to war, it doesn't nearly compensate enough. So they're not entirely sure. It could be leftover mating strategies. It's roughly 50-50. It also could just be, evolutionary accident in that it's close enough to 50-50. Evolution just works with what works, not what is exact. So, color blindness. On your X chromosome, you have all of the traits you need to see. You have all the rods and cones being coded for. There is nothing on the Y. This is why it would be extreme. Notice, we do not have a child that is YY. Double male. That would be bad. You'd be lacking a huge number of genes and amongst other things. However, since it's carried on the only on the X, it affects males and females differently. So what we call, I don't want to call it normal vision because all vision is normal. So trichromate vision we would call full color vision. And if you are colorblind, there's a lot of different variations. It depends on the specific type of rod and cones that you inherited. So you can be blue-green colorblind, you can be purple-red colorblind, a variety of things. Sir?
Is there like a specific side it comes
A specific side?
Like your mom with that.
Because it's an XY gene, who did you have to inherit it from? Mom. So if your dad's colorblind, and you yourself are genetically male, you'll never be colorblind from your dad. Now, a person who's colorblind, their daughters or genetic daughters may end up being carriers, but they can't get it from their dad. They have to also get it from their mom. So if you're colorblind, you got it from your mom. If you're colorblind and you're female, you got it from both.
Can't, I thought it was 60% of women have a fourth one for seeing like extra reds.
No.
And it was like 5%.
Right now I'm doing colorblindness, and the fourth one is
But
just
saying it's
is just that one. It's just the colorblind. There's lots of them, and I'm not going to go into the detail of which ones, but there isn't a separate gene. There's just other forms of it. So if you are a carrier female, what you're talking about, let's say trichromate vision, which is R, and color chromate vision is R. But this one, if you have it, you're colorblind. But if you have it and you also have access to the regular one, that means instead of being colorblind, you actually just have extra information. So if you are a female and you're a carrier, some of those females actually have super color vision.
Yeah, and it's also, I thought it was also found in like 5% of males, but like 16% of females.
No, if you have that in your male, you're colorblind. Because you don't have access to, you don't have two, you only have one. Unless you're talking about a completely different rod or cone. On the colorblind one, if you're male, genetically male, you only have one gene. You're stuck with that one. Okay, so let's go with male, XRY, female, XR, X little r, you're a carrier. Fill it out and fill in all of those percentages. What is the percent of colorblind male, trichromate male, colorblind female, trichromate female, and carrier female? And we are just using capital R and lowercase r, but there's a lot of different lowercase r's. There's different types of colorblindness that you can inherit. Ooh, we just have a minute, so. Just realized the time, so I filled it out and I'm not going to ask you.
Does the X always go first?
Pardon?
Does the X
XO
always
alphabetical order. So first one, Hugo, how many colorblind males?
25%.
25%? That's right there, 25%. Don't pack out, or this will take longer. Felix, how many trichromate males? 25%. That's that one. Zoe, how many colorblind females?
50%?
Which ones? Which ones are colorblind?
Both?
No,
No.
capital R is regular.
None are
Like
colorblind.
trichromate, all your rods and cones vision. So you'd have to have little r,
0%
Zero.
colorblind.
so 0. So which one of these, what percentage, Zoe, has trichromate female?
25?
25. Because we're distinguishing between carrier, which is the other 25. Now, before you go, this was handed out the day I was gone. If you've not done it, please make sure you're done. Did you not get this? You wrote a quiz and then you picked this up at the end?
I wrote the quiz like.
And then on your way out right now, please pick up this one. If you did not get either, you've got two to pick up. You're welcome. Matthew, did you look up which one, what the gene that they were talking about?
Oh, thank you so much.
I'm having trouble knowing what this is.
Okay, I grabbed two. Grab two. You told me to bring two people that I didn't do that project with.
Let's say hypothetically, there's 5 people. Let's say hypothetically, those stuff. Okay. Came.
I know that was good.
That one, and then that one, did you get this one? Okay.
Wait, getting into me, bro?